Welcome to ING Tech Hangouts. I'm Marv, I'm a front-end developer, and I've been doing this for 10 years now. Whenever I'm not coding, I'm usually tinkering with one of my 3D printers. This is my colleague, Mihăiță.
Hello, I'm Mihăiță. I'm also a programmer, a Java programmer for more than 10 years now, and I think that in our role we are on a continuous learning mode, and I hope you will enjoy the presentation today, and maybe by the end of it you can also have a good idea on what you can do to help your end users to forget about their passwords. So I think we can get started.
Let's take it away. As developers, we naturally want to provide our consumers with the best possible solution, but also keeping in mind to ensure good security. So recently, Mihăiță started working on a project, and he asked me if I have heard of Web Authentication. I didn't at that time. I didn't know anything about the subject, but I did a little digging, and I saw that Web Authentication is a web API, so you could use the platform, the browser capabilities. And then I got curious as a front-end developer. I wanted to use it, to learn more about it, and we started working together on this project, implementing Web Authentication, and see how we could go towards a passwordless future. And we learned a lot of things along the way. For example, did you know that the average online user has over 90 accounts? That's a lot of accounts, and probably some of them even reuse passwords. Can we see a show of hands here? I'm curious if you've reused the same password for multiple accounts, maybe in the past. Okay, there are a few. And if you're not reusing the same password, then you probably have a good algorithm to ensure a good policy, or maybe you're using a password manager. But even then, we'll see that you're still exposed to some sort of attacks and vulnerabilities. Let's have a look at the agenda for tonight. So we'll talk a bit about what authentication is, how do we use it, some of its challenges, and then we'll jump right into Web Authentication. Give a brief introduction on asymmetric cryptography, because that's what we'll be using behind the scenes. Go for the main ceremonies, explain them, and do a demo on each ceremony to better understand how we can use them. Go for the resources that helped us learn more about Web Authentication, can help you in your journey, and see how platform support is these days. So let's start with authentication. From the Greek words authentikos, which means true, real, and authentes, which means author, authentication describes the act of validating that the user is who they claim to be, and is usually required when the user wants access to protected information. And no matter how you choose to implement authentication, you're probably going to need to use at least one authentication factor. And an authentication factor is just a specific category of security credentials used to identify users and validate that they are who they claim they are. And I'm sure you're familiar with most categories that you see on screen. Some of the most common, so something you know is a password, which many of us use. Something that you have could be a software token, for example, Google Authenticator, Microsoft Authenticator, other TOTP authenticators. Or it could be a hardware authenticator, such as an RSA Secure ID. Something you are is a biometric, so for example, face recognition, voice recognition, fingerprint recognition. And perhaps a few of the more interesting ones. Somewhere you are is tied to geolocation. And you can think of an application here, geofencing. For example, a company could choose to implement authentication for its employees only within a certain radius of their building. Something you do is tied to personal patterns and user behavior. Another example here is Windows 8 that introduced the picture password. When you logged into Windows, you could choose a personal image that you would perform some sort of actions on to get access to Windows. So for example, clicking on various elements within this image. Now, we need to use an authentication factor to implement authentication. And actually, the industry suggests and encourages us to use more than one, so a combination of multiple to ensure good security. And each of them, so each authentication factor is vulnerable in a certain way. And certain data reports and show that 80% of data breaches are caused by exposed credentials. so credential theft in general. And that's because passwords are vulnerable to brute force attacks. They're vulnerable to phishing. Credential theft can happen because of application vulnerabilities, for example, maybe a 0-day, lots of reasons why you could lose access to your credentials. And I'm wondering here tonight if there's anyone that has had their credentials exposed in the past, if you've done this research for yourself. I know I have, so I'm going to be really honest about it, and I'm going to show you. Just using the site. I've moved away from one of my email addresses, but I've used this for 10 years or so. And if I do a quick lookup, I can see that I've been at least involved in 31 data breaches. And there are big companies behind this, I can assure you. So even LinkedIn is among them. I think they've had a data breach somewhere in 2013. And since I moved to a newer address, I guess my behavior online has improved a bit. But maybe security has also improved along with us during the years. So we've seen how authentication works. We've learned about a bit about authentication factors. There are vulnerabilities. Phishing is an increasing one that we see evolving from day to day. They're getting more creative. And let's see how web authentication can actually help us eliminate a few of these vulnerabilities. And I'll give you a short spoiler. Phishing is completely removed from this. But I'll let Mihăiță tell us a bit more about web authentication.
Thank you, Marv. So let's see. How many of you already heard about web authentication or maybe use it until today? Okay, so I think there are 10%. So web authentication is a specification created by W3C and the Fast Identity Online Alliance, FIDO. And this is a group of big companies that are trying to deal with this password issue. We saw earlier there were many workarounds to protect the passwords, but in the end, this problem, we can deal with it by completely removing passwords and replacing them with strong, attested, and scoped public key-based credentials. And in this picture here, you have your usual web application. It's called a relying party in the web authentication terminology. And usually your application will be consumed by a client that will use a user agent, a browser. And what's new in the picture here is the authenticator. And that's a device. It can be either built into your machine, or there can be also some external key. Your machine will connect via USB, Bluetooth, NFC, and so on. And the end user, with passwords, they had to remember it. But with these authenticators, they will have to have access to them to prove their presence and identity. And before going any further, we just align a little bit on this asymmetrical cryptography part, because we are replacing passwords with strong credentials. And in this landscape here, you have this public key, private key pair. And while anybody can have access to the public key, the access to the private key is controlled via some secured, well-defined process. And when you send a message through a channel, you get a secure transmission if you apply an encryption using the public key, because only the one having the access to the private key can understand the original content of that message. If you apply the encryption with the private key, anybody can understand the original content, but you are still getting something out of this. Because of that control process around the private key, you have the guarantee of the identity of the sender. And this is what web authentication does. We create strong, attested, and scoped public key credentials. And we have several ceremonies. We have this registration flow where you have to create these credentials on an authenticator and move the public key to the relying party so that it can, later on in the login ceremony, it can validate the identity of the user. But of course, we don't want our end users to be locked out of their accounts, to lose their important data. So there is a recovery account flow. And we also want to improve the web authentication specification with something extra. And we come up with a few alternatives to enhance the user experience by allowing them to add more devices easier. And here you are seeing in the screen the usual sign-up page. We removed almost all the fields, especially the passwords, and we just kept the username. Now even the username in Web Authentication, it's an optional field, so we could register a new account in a relying party even without any data. So an anonymous user could be added. But here, for similarity reasons, I will have to create a demo account. And right now, in the center, you are seeing a stream of events from the relying party, and the browser asked the relying party to create a new account, demo. And the relying party is also building a set of constraints, and those constraints are being sent by the browser to the authenticator to create the set of public key-based credentials. And now, here, if you're not seeing well this, it tells me, the end user, to verify my identity with this domain. I'm choosing this device, so the platform authenticator that's built into the computer. And after proving my presence and identity, I'm seeing here a successful message, and I get a recovery token. From the logs here, we can still see some useful information. So I can see the domain of my relying party application that will be used by the authenticator to scope those credentials only to my application. So no other relying party, no other website can have access to my credentials. And this is very important because at some point, maybe your end users will be tricked to click some phishing links. But in the end, you will be able to validate authentication requests coming from unknown domains. Now we will authenticate with this user demo. And usually, for example, in the form login authentication, you have one request sending the username and some credentials, and then the server will respond with a session, and you have this authenticated user. With web authentication, this process happens in 2 steps. So the first step is the browser to ask the relying party to generate a challenge. And besides that challenge, there is also an extra information here. You can see the public key ID in the logs, and this public key ID will end up to the authenticator. And now the authenticator recognizes that ID and will ask me, the end user, to prove my presence and identity. And only after pressing my fingerprint, the authenticator can read the private key, use it to encrypt that challenge, and send it back to the relying party. Now, there are a lot of messages here, but in the end, the relying party decides that this is a valid authentication request coming from this domain, and this is a whitelisted origin, so the request is good, and I am being logged in here with this demo account. Now, I will log out and hand it over to Marv.
Thank you, Mihăiță. Let's have a look at our third ceremony, and it's about recovering access to your account, because we've seen that these credentials sit on physical devices, even if it's a platform authenticator, in this case, a laptop, or it could be a roaming authenticator, some sort of external device that you carry with you and holds the credentials that you could move from one device to another. These things can be misplaced, they can be lost, they can even be destroyed. So if you have only one set of credentials associated with your account, that means that if you lose access to them, to that authenticator, then you will lose access to your account. That's why, if you remember in the registration step, we had the recovery token at the end of the flow, which we should have stored in a safe, secure place, just in for such a scenario. So thankfully, Mihăiță saved our token in the secure place, which is the clipboard, and I can now use it to recover access to my demo account. And the moment I press recover, you'll see that a similar process with registration and also login begins. I'm yet again asked to choose how I want to verify my identity, so I could use a USB security key or this device. Since this is Mihăiță's laptop, I don't have access to his platform authenticator, in this case his fingerprint. But I'm also a latchkey kid, so when I was small I used to wear the key around my neck, and I carry to this day a roaming authenticator that I could use to prove my identity and create credentials and store them on this key. And so I will choose the USB security key option. I have to activate it for a moment, and since this is a roaming authenticator, this can also be stolen, right? So then what would happen? Anyone could use your credentials. But that's why this has an added measure of security and requires a PIN that I've previously set up. So I'm going to insert my PIN and then prove my presence again on the device, and we see that the recovery has completed successfully. And now we can actually test this out because this recovery key was associated with the demo account. And if I go back to login and hit demo, you can see that I can choose my security key, prove my presence again, and log in using these credentials on my roaming authenticator. Now there's something worth mentioning here in the recovery flow because the moment you initiate it, it means you're under the assumption that you've lost access to all other credentials. And what happens when you're creating a new set of credentials using your preferred authenticator, you're uploading the new public key, but you're also purging whatever public keys are already associated with that account on the relying party. So everything else is destroyed, and only this new key that I've attached now is available to use with that account. But we live in a more complex world than that, and we probably want to access our account from multiple devices, so several smartphones, laptop combinations, and so on. And that's why we did a bit of digging into the adding a new device flow, extending your access across multiple platforms. And the W3C specification for web authentication provides an example of how you could do this. It implies using a roaming authenticator, so such a USB key, and your credentials will sit on it. You can move from device to device, and once you log in using the credentials on this authenticator, inside the dashboard of your relying party application, you would then tell it to also enroll the credentials from the platform itself, move to another device, repeat the process, and so on. But you would be dependent on a roaming authenticator. And we thought maybe we could improve on this because not everyone has a roaming authenticator. Maybe you don't want to carry it. Maybe it's too expensive for you to want to buy such a thing. And we thought that we could improve the process and eliminate the roaming authenticator. We came up with 3 scenarios, and starting with the simplest one. From the device you're already logged into, let's say the smartphone in this case, you have access to it, you would go to your dashboard, to your profile, and generate some sort of token. Using this token, you could move to any other device and generate a set of credentials that would be associated with your account based on the token. By the way, the token is short-lived, right? So only 10 minutes or so, because we don't want to misplace it, use it, someone gets access to it and then associates their own device to this account. This is the simplest way we could think of, and that would mean that you would move this token manually through either medium, so send it through WhatsApp, through email, or even type it manually. But these tokens are random strings. They're large in size. They're hard to type. And I personally don't trust sending it over WhatsApp, especially not for this case. So we thought we could improve upon this version and thought of sending it maybe through WebSockets. On the relying party, let's say there's a WebSocket server, and then facilitate communication between the 2 devices you wish to enroll, one you're already authenticated in, and a new one, and then set this registration add token through the WebSocket. But even then, maybe your business case means that a lot of users use this concurrently. There are a lot of flows that are happening at the same time, or maybe they take too much, and that means sockets being blocked. Lots of open connections on your relying party. So we wanted to eliminate this problem as well for the relying party, and we built upon it and introduced Webrtc for real-time communication API, which means we use the WebSockets just for a moment using the relying party, introduce these 2 devices. They join a room on WebSockets. They find out about each other, find their public IPs, how to get past VPNs, networks, routers, and such. And then using the Webrtc protocol, they can then communicate peer-to-peer, because they've now discovered each other. We can close the connection through WebSockets, and it's up to them to send whatever data they wish between them. And this is the exact scenario that we want to demonstrate here tonight, the one with Webrtc. And I have half of the flow on my side, and this is an unauthenticated account. Mihăiță is signed in into his dashboard on his smartphone. And I'm going to generate the code here, which is the room code for that WebSocket channel that we'll use to establish communication between the two devices for them to find each other. And I see Mihăiță already inputted the code on his device, and I'm met with an acknowledgement. It says, I understand that this device will be added to Mihăiță's angel emoji account. And this is important because in most cases, you're probably the same person on either end of this device, but you also want to make sure at all times that you're allowing access to your account and you're sure of what you're doing. So I don't have the registration token yet, but the moment I do acknowledge this, I send a request through Webrtc, a message to Mihăiță, and say, hey, I know what I'm doing. I agree to enroll these credentials to that account. And Mihăiță sends me the registration token as a response. So right now, if I hit enroll device, again, a process similar to registration happens. Now choose the USB security key again, provide my PIN for this key, prove my presence, and right now, I can also sign in to Mihăiță's account, which he's also logged into on his device. So if I quickly jump back to the login and copy Mihăiță's angel emoji username, you can see that if I input the PIN again, prove my presence, I now have access to Mihăiță's account. Now you've seen the main ceremonies. I think you have a better idea of at least how it works and how they tie into each other. But this is just a demo, right? We're all developers here, and we're probably curious about how things work under the hood. How do you set up a relying party? How do you ensure that user accounts are connected how they should be? So for that, I'll let Mihăiță tell us more about the Spring Boot starter that he built.
Thank you, Marv. So, yeah, this is a demo. Things are working, fortunately. And actually, what we aim to do is that maybe after the talk, you can also make your own steps towards passwordless applications. And there is this Spring Boot starter, a community contribution that we hope others will embrace. So if you are into Java and Spring Boot, this is a good place to start. But if you are using something else, maybe you can take the lead and make your own contribution there. So usually in a Spring Boot application, you can add a dependency, and then you are good to go. This starter builds up on the Spring security layer, and usually you just have to enable Web Authentication like all the Spring magic does. You are adding a new set of beans that will allow you as a developer to store user data, credentials, things specific to Web Authentication. But the library does that for you. And you just have to add something on top of your existing authentication methods. So you just have to add the new Web Authentication configurer, and then you can also get a few callbacks that you can use, maybe to react on some events a user just registered, maybe someone logged in, and you can also have this kind of freedom. Now, the next best thing to do is to go into the application. But before that, it's only a small detail. I said that the strong, attested, scoped, public key-based credentials get created by the authenticator. Then it means that the relying party, your application, has to provide some details for the authenticator. And here you have to define basic information like the domain of the application, and that set of origins that you can accept authentication requests from. Besides that, the library also automatically registers a few endpoints, and maybe if they don't fit your current API design, you can also rename them. Maybe you also prefer to enforce specific encryption algorithms, and you can also do that. Now I'll just copy this dependency here. It's a minor release. And we will move to this classic Spring Boot application. It uses Spring Data to save users. So this is the implementation of an existing legacy user because they are using username and passwords. And this application should do something useful for a demo. And we will also have accounts associated to those users. Now, when the application starts, there is an initialization happening here. We create 10 users with some accounts. And let's say our business team just decided that passwords are bad, and we have to add web authentication for new users. So we will just have to import this starter here, which, by the way, uses the Ubiquitous server, relying party server implementation behind the scenes. And let's make sure Maven knows about this. So the first thing to do is to enable web authentication, so the Spring Magic here. And besides the form login authentication that the application already has, I will also add the web authentication part. So I am applying the new web authentication configurer, and here you can also see some documentation on what it does. So there are a few extra informations that you can look into detail later. We added the Java code here, so not too much, but we also have to add the relying party information. So I'm also copying this information from here because it's a localhost application. I don't bother with other domains, but here is the place. Maybe you have an auth something domain of your application.com, and you can add it here. Now I think it's a good moment to start the application. So we did some minimum changes. And let's see if it compiles. And in the few seconds, it should also start. Now I'll go to the default form login page. I can log in with an existing account. So this user with its password will redirect me to a default page. So maybe it's good. And I can see here that I have this username with some password. And then I also have an account. So the business requirement was to allow new users to register with web authentication. So I will log out now. And we did the relying party backend stuff. Yeah, the library just promised us that adding this will expose our endpoints, but then we are faced, like in this browser, we should display some pages to allow you to do all those flows with registering, recovery flows, and so on. And there are some things that you can also use from this library. So I will go here. So you have the Java goodies with the things that the library does. And there is also something extra. You can get here an up-to-date documentation specific to that version you are using. And if you open it, you can get all the flows described in details with the request payloads, responses, and so on. Maybe you can help us with a contribution to detail this even more. But the most important thing is that you do have examples of authentication requests and responses, and you can maybe better understand how this works. Now, there are also other things that should help you. And there are some front-end resources, ugly pages, but they should work. So there are different web components created by Marv, so also a contribution to the community. Then you can configure them for your relying party implementation to expose some default pages. And all of them are placed here in the resources web authentication from this library. So the next thing that I have to do is to expose the resources in my Spring Boot application. So there should be a property here, web resources static locations. And from the class path, I can use this location to expose some pages. And let's see how this works. So we had here the form login authentication method. I am typing the username and the password, but now I want to use a different login page to authenticate with my fingerprint. And now, because I exposed those pages there, I can go to see that ugly page. It should work. We will use it in a minute. But the first thing that I have to do is to register a new account. So I use here demo. And if I'm pressing this, maybe it's good to also see the network information from here. So registering triggers. I won't use your platform authenticator, your roaming authenticator, Marv, so I'll unplug it. I don't know the pin. And now I'll use my device, the platform authenticator, and with my fingerprint, I'm able to create a new account and a new set of credentials. And here you can see, well, if I would preserve the logs, we will see now. When I'm logged in, I can see some the two requests. So the first one is to generate the challenge, and the last one is to, on the assertion finish, is to validate that the signed message from the relying party is valid. And I am redirected into the default page. I am seeing my currently logged in user is demo. I don't see the password, but I do see the recovery token. Don't do this in production. But yeah, there is also no, I don't see any accounts yet. Maybe the business team just decided to, hey, let's create new accounts for our new users because we want them to be happy. And now is the good time to replace the default implementation from the library. And let's say on this register success handler, yeah, you can use it to get the newly registered users. So here, I should get the user. And now I want to create a new account because this is what our business team just requested. So in this application here, an account is something very simple. And we just create it very easily here. So account, it's just something containing a name, and it's related to some user. And here, I can get the user from this object here. And now this object, it's something related to web authentication. It's something that the library will expose, and it has some basic information. And the account, let's say, it also has to have a name. This account is something like account minus, let's say, system current millis. And we just also have to save it. We can save it with the account repositories from Spring Data, like this. And now we can start the application. So if I'm going again here, we should see new accounts added for our users. Unfortunately, I have to log in again because we were a little lazy and we use an in-memory database. But yeah, we can add a new account easier. We don't care about a password. And now I can see that new account with that name associated to my new demo account. Well, our business team just decided that web authentication is actually a good thing, so we want to migrate existing users to web authentication also. And fortunately, the library also allows us to react on some authentication events. So whenever you want to register a new set of credentials, the library can check if there is an authenticated user. Then it means that you want to create credentials for that authenticated user logged in with a form login method, for example. So let's see how this works. With Spring Security, you can get the currently authenticated user with security context holder, get authentication, and now this authentication object here, maybe it's something let's move this here. Maybe this is something, it can be something null if you access like an unprotected page, and that page would be the register HTML page when you set up a new account, so this can be null. And if that's the case, then it's safe to say to the library that, yeah, don't look to any authenticated user because there is none. But if there is an authenticated user with a different authentication method, then you have to translate what an authenticated user represents in your application to something that the library can understand. And the place where the library stores its data, it's in a Web Authentication user repository. And if you don't use Spring Data, for example, the library will create some in-memory representations for a user repository. But if you don't like that and don't want to go into production with some POC repository, and it's a good idea to not do that, you can create your own implementation and store the end users to whatever system you like. And now we have to return in this user supplier. So yeah, you have to provide something to the library. And here you have this Web Authentication user repository. Maybe there is a chance that there is an user that the library knows about, and we might return that. Or else, maybe it's a new user, and here we can translate from what the user is in your application to something that the library knows. And we have to return a Web Authentication user. So this is a new user. OK. And on this user, we have to set at minimum the username. So authentication, get name. Maybe, and there are also some other properties here. Maybe you want, I don't know, enable, disable them. Let's just keep this true. And we should not forget to also save the new user. And now, this should be our new user. And our user supplier here will provide us from the security context an authenticated user to the library, and we can start it again and see if we can migrate legacy users that are using passwords to new type of credentials with no passwords, and use your fingerprint. Don't bother, just press it once. OK, so we can go back here again. I am redirected to the login page. I do have to register with the legacy user, so with my password. And yeah, this is the user. It has a password and one account. Now, there is another page from the library, credentials HTML page. And in this page here, all it does is to add Web Authentication credentials to existing users. So let's also open this. Maybe it helps us. Now, there is a request to register new credentials. And the library just called our user supplier method. And from the authenticated object, it knew that it knows that there is a user 0 already logged in. And I can use this device to create that new set of credentials. And yeah, the default behavior of that page is to redirect me to login HTML page. But I'll also log out just to be sure that there is no authenticated user here. And right now, I can use this. Actually, I think we'll close it. So I can log in now with my fingerprint, and I'm seeing user 0 here. I don't have any password because this is the representation of a user in the library. And I do see two accounts, the old account and the new account, because that's what business team decided to create new accounts for for users creating Web Authentication credentials. Maybe just to have a quick question, what would happen? Maybe you can intuit what would happen if I try to register. So I'm an unknown user right now, so I'm in the logged in page. and I want to register as user 1. So I want to register a new set of credentials for user 1. User 1 is a legacy user already in the system. It has a password. And now I want to create a new set of credentials for this already existing user. Can I do it? So maybe who thinks I can take over this account? It has a password. So is this like it shouldn't, or? Okay. Other opinions? So this page here is that web authentication web component that will always request for public key-based credentials. So it won't ask me of a password. So it's not the login page from Spring. Okay, so let's add a breakpoint here and see what happens. So right now, actually, yeah, is the register HTML. Okay, so user 1, and right now the library will look if there is already the logged in user. But we didn't authenticate with user 1, so this is now. Yeah. And now, maybe it's also a good idea to look into what the library does. Okay, so there is a filter here somewhere, Web Authentication. This is a registration. Okay, and at some point in the library, okay, so at some point in the library, unfortunately the breakpoint didn't activate. At some point in the library, it looks if there is an authenticated user. In our case, it wasn't. So the library will use the Web Authentication user repository and search the username. Now, the Web Authentication user repository didn't know about this user 1 because we didn't migrate it yet. And actually, let's move back here. And actually, we can see here. Okay. Well, long story short, it allows us to create a new set of credentials. So let's, now this is the first call to create that challenge. I'll just resume it. And I'm getting a successful response here with user 1. So the main idea of this part is that you also do have to migrate that, you do have to take a data migration decision. So if you want to migrate your users depending on their activity in your application, you can migrate them on the flight, like we did here. When they log in, they can access that registration page. But you can also take the decision at some point in your application to also associate your user representation to something that the database from our library knows about. So here would be that place to create this web authentication user. But now, yeah, this is only just some translation from whatever your application does to this library. And here would be just, you just have to set the username. Maybe in your application, a user is more complex, and you have to do the proper mapping between them. Okay, Web Authentication user repository, and yeah, that's the void. that should be it. Okay, I think we don't have more time to go any further in other details, but we will ask you to maybe provide us some questions at the end. So I'll leave Marv now to take over for the next part.
Thank you, Mihăiță. So Mihăiță showed us a really simple way and flexible at that to get started with web authentication with the Spring Boot starter, where you can use it outside of the box with its defaults, or even configure some of the properties or how you want it to migrate your users. But that's only half of the story, because there's also the consuming part. There's the client side. This is only the relying party setup. And if we have a look at what it means to use it on the client side, I think a good resource for this is webauthn.guide. And this is what the site looks like. You can go visit it today, learn more about web authentication, find out what problems it solves, maybe even more detailed than we provided here. But you can also see some of the examples of using the web authentication and the credential manager API that it uses behind the scenes natively in the browser. And you can see clear examples. We showed 4 ceremonies here tonight, but all of them just use these 2 functions provided by the credential manager API. So either create or get credentials. Using the credential manager API, you can create your public key, private key pair. And using the get function, you can retrieve your private key and use it to access the web authentication API and sign the payload provided by the relying party. And if you have a look at what create takes as input, you'll see that a public key is required, and that's actually public key credential creation options. Real mouthful, but not as large as the payload and complex as the specification wants us to provide, because in the spec, you'll see that some of the fields need to be provided in binary format, because that's how the credential manager API deals with them. So maybe the challenge, the user ID, and there are several others that you need to use as maybe a binary array or some sort of a buffer. And this could be tedious to work with, because whenever we're using implementations for relying parties, we usually do REST, and REST transports the data over JSON. In most cases, of course, you could have different implementations, but the majority that use JSON, you will know that through JSON we cannot send binary data, so it needs to be encoded in some way. We can only send strings, numbers, so really simple primitives. And because of this, on the relying party, we need to work with buffers, binary format, and on the client side, on the authenticator side, we also need to work with binary format. And that poses the problem of sending the data over the wire, which means the relying party transforms encodes to maybe a base 64 string, send it over with JSON, and then the authenticator decodes back into binary, and so forth when I upload my credentials to the relying party. And this can get complex really fast, and maybe you'd want to avoid such boilerplate. And that's why we also provided a set of web components, so native web components in ES module format that you could use in any evergreen browser, new browsers, and in combination with any framework you choose to use. And you can see here a simple example of just importing them as a script type module and then dropping that WebAuthn login, for example, component, and you'll be provided with those, let's say, white label pages that Mihăiță showed, the ugly, simple form pages. Or you could choose to use them in, as I've said, framework or library of your choice, be it React, Angular, Vue. It doesn't matter. As long as you're using ES modules, you can import it. You can insert it in the DOM, maybe into templating or programmatically using document create element. And we also expose many properties that help you configure them. And some of the properties even match one-to-one the relying party configuration you saw in application properties. So for example, assertion start URL if you choose to modify it to fit your business case, you can also change it on the web component, again, with dot, a search and start URL, and have it match what your relying party needs to consume. But we don't want them to look for everyone like simple, ugly forms. So we also provide, and we expose CSS parts if you're familiar with the specification. That means that each element inside these components, the form, the labels, the button, the input, they're exposed and are easy for you to style in whatever manner you choose to. So they can match your branding or your personal preferences. And if we go a bit into the resources, we encourage you to have a look at our Tag WebAuthn organization on GitHub. And you can see here, it has 3 projects inside. So it has the web components, which are also published on NPM. It has the Spring Boot starter. And it also has a demo application that uses both of them. And they're all open source. You can contribute to them. If you find issues, open issues or fix them yourselves, bring improvements, whatever you wish. You can read more about what we do on web authentication on Twitter, on Medium, and you can learn more about web authentication and deep dive into it, because an hour is really not enough. Following the WebAuthn guide site, reading more about what the FIDO Alliance stands for and how it pushes a passwordless web. Read about the Web Authentication API on the Mozilla Developer Network. And there's no excuse for not trying it, because you don't even need a roaming authenticator or a platform authenticator. Maybe your laptop doesn't support any type of authentication. Chromium browsers have a built-in web authentication simulator. So you can just go to any developer tools in a Chromium-based browser, go for more tools, and at the bottom, you'll see WebAuthn. And once I enable the virtual authenticator, you can see that I already have one active, but let's say you're starting like this, and you can choose what type of protocol you want to use, the universal two-factor or CTAP2, and then choose what type of transport you want to emulate. So maybe USB, Bluetooth, NFC, or an internal authenticator to see how it would look like, and to really bootstrap your application and see how it behaves. At the same time, you've seen demos, you've seen how to implement the Spring Boot starter. You've seen that you could use a couple of components to get you quickly started. And I'm sure there's been a question on everyone's mind since the beginning, okay, but can I really use it? Does it work everywhere? So why should I adopt it? You know, we have lots of business case requirements. Maybe some of you still need to support Internet Explorer, for example. I hope not, but I hope that died a long time ago. But let's have a look at browser platform support and then at roaming support. And if we have a look at the table on that screen, we see that support is really good across the board. Windows 10, iOS, there are some quirks there, some differences. For example, new Chromium browsers like Brave. Brave tends to implement its own things, its own APIs, interfaces, and how it handles user behavior. So they haven't fully integrated everything. But I can assure you, once they finish that, it'll look really nice. I've tested at least with roaming support, and they have a different experience from all the other Chromium browsers. Unfortunately, desktop Linux support for built-in authenticators is not really present, because it's really hard to interface with, I'll give you an example you can probably relate to from the news, with the TPM module, because that's where your credentials are stored, in the trusted platform module on the device. And that's really not something that Linux provides outside the box. But if we move on to roaming support, so using external authenticators, such as this USB key, we can see that everything should work across all combinations. Even desktop Linux works with all Chromium browsers, with Firefox, and every combination that makes sense, of course, so you won't get Safari on Linux. And Brave is still working on Android support, but iOS works really good. But again, this is all nice, and the best experience that you could have is the one you see for yourselves. And so we encourage you to try this tonight. Right now, you can go to auth.marv.ro and check out a demo application using Web Authentication where you can register an account, go through the recovery flow, add new devices, log in, check your dashboard. And in the dashboard, you'll see your user agent that you've uploaded your credentials from. I see a user already created an account, Mihăiță. This is live, by the way, so if you create an account, it will appear on screen. You can leave feedback for us if you wish so in the dashboard of your account. And I hope we sparked a bit more curiosity on web authentication and that you're eager to learn more in the future, just as we are.